Hi, nice that you're watching the SAI Conference 2015. My name is Lars Sørensen, and we're here in London talking to participants, keynote speakers, exhibitors of the SAI Conference. I hope you will like this short interview we'll have with one of the keynote speakers. If you like, don't forget to share and subscribe to the YouTube channel. So we'll be sure to sending you all the updates and all the content of this conference. I will be talking to one of the keynote speakers. I have the pleasure to be with here just a few minutes with Karlheinz Meier from the University of Heidelberg. We just saw your keynote about brain computing, and my brain just went berserk on all the information that you were sharing with us. And obviously also you start imagining things. So are we going to put brains in computers or computers in brains? Where are we right now if we look at the field of brain computing?
Well, there are two questions that we want to address. One is indeed to put brain in computers to understand how brains work. And that's a very successful field. It's called computational neuroscience. But there's also the other way. We know that brains do interesting information processing, and they do it very efficiently in terms of energy, time, and resource usage. And so putting brain computing into new computing architectures is a very, very important field of research, and it's actually my field of research.
Yes. Could you elaborate a little bit with us? You obviously you had a keynote of half an hour, 45 minutes, so we cannot reproduce the entire thing. What would be like the main thing that you would like the audience of the SAI conference, which is very diverse, where are the chances for them to profit from your research and the
Well, I try to make the point what makes the brain so specific and so attractive in terms of computing. I mean, it runs on very little food. I said it's a banana per hour, which safely keeps you running. It's very compact, obviously, much smaller than a supercomputer. And maybe the most important thing is it doesn't need any software. You never update your software in your brain. In contrast to your cell phone, you have to recharge it all the time and you have to update it all the time. Nothing like that for your brain. Just eat bananas and learn. And it's the learning aspect that is so important. We learn by interacting with the environment, and then we can take very complex decisions. I brought the example of having a very unusual picture. I showed a blue cat with wings.
Yes, I saw that. Yeah, there was a 200 millisecond experiment.
Exactly, it's a 200 millisecond experiment. You have never seen that before. It's a total surprise, and yet people were able to interpret it. And the fact that we do this so efficiently in only 200 milliseconds with so little energy is that we spent many years before doing the necessary learning by interacting with the environment, by looking at cats, for example. We know that there are no blue cats. Cats don't have wings. We learned that during our life. And to implement the learning process in artificial systems is, to me, the biggest challenge, but also the most rewarding aspect of brain-inspired computing.
And are we managing that? Because obviously I understand a human will be having all those years to program the brain and reprogram the brain. Like you showed us the picture from the age of 15, we're rewiring non-stop. So how long will it take that we're that far that we can teach the computer systems to?
That brings us to the aspect of time, which is a very important one. If you run brain simulations, they typically run slower than biology. So if you want to simulate a day of learning, it will take you months, if not years, to run a computer simulation. So that's not very practical. Even if you have a real-time system, it will take a day until you have simulated a day. Also, that is a very slow process if you want to build an artificial system. This is why in our group in Heidelberg, we decided to go for what we call an accelerated system, where we compress time, actually by a factor 10,000. So a day is compressed down to 10 seconds. And we hope that with this system, which now starts to work, we can implement learning processes on a very short time scale and really make systems that interact with data and then learn to make predictions and take decisions.
Why would we? Because obviously this is like a trailer for our viewers, maybe to trigger them to watch also the entire keynote that we'll make available on the YouTube channel. So make sure to subscribe and watch it. What will be like the 2 or 3 main conclusions or takeouts for people to focus on when we're talking about the neuromorphic computing and the brain computing?
Well, the first important thing, it's worth it. Because clearly I described the features, energy, efficiency, time, learning, and so on. So it's worth it. It's worth to invest into these things. Also for young people, by the way, if you are looking for an interesting field to study, I think this is a field to go. And secondly, it's being done. I mean, we are building systems. These are not just crazy ideas. There's a lot of activity in the world. And Europe has quite a good position here. There are two major activities, one at the University of Manchester, here in the UK, a group led by Steve Ferber, a system based on ARM processors, the ones you have in your telephone, and then our approach, which we call the physical model, where we build these accelerated systems that I just described. So it's worth it, and it's being pursued, which is very important, I think.
Nice to make this little step to Europe. Is Europe also supporting this field of research? Is there a focus on it? Because obviously we're in London now, you're from Germany, so is this a focus within Europe? Is there a budget for it? Are there sponsorships?
Yes, absolutely. I'm glad that you asked that. Actually, at this SAI conference, we had a presentation by a representative from Future Emerging Technology, which is one of the research programs in European funding. And FET, Future Emerging Technologies, has been really very visionary, not only recently, but over the last 10 to 15 years. Our research has been really mostly supported by European research funding. And I think, I dare to say, as a result, Europe is very, very competitive, even with our friends in the US, where, of course, this is also being pursued. So I think this is a great example of European collaboration.
Then finally, for you, as also a participant and a keynote speaker, the SAI Conference, what makes it different from other conferences for you?
Well, it's broad. That definitely makes it different. I usually go to conferences where I talk to theoretical neuroscientists or people building electronics, and I never meet people that ask questions that are surprising to me. I would call them the blue cat questions. So the blue cat was a surprise to you.
Yes.
Now here, if I talk over coffee and lunch to the people ask me very surprising questions, and they make me think. And I think that's very important.
Good to hear that. Thanks for your time. We were talking to you shortly. If you want to hear more of Mr. Karlheinz Meier and the entire keynote, please look it up on our YouTube channel. We'll make it available for you there. All the information about the program that we had here at the SAI Conference 2015 you can find on our website. Thank you for watching. If you like this video, please press share, press like, and make sure that we keep sharing and making new connections. My name is Lars Sørensen, and I hope to see you here next year.